So alkenes. Alkenes are unsaturated hydrocarbons. After alkenes are most important. Basically, alkenes are derivative of alkanes. Alkanes are primarily present in the nature. How? In the crude oil. When crude oil is fractionally distilled, we get a large variety of alkanes. From methane, ethane, propane, butane, gases to petrol, to furnace oil, diesel oil, kerosene oil, jet fuels, and lubes, lubricating agents, waxes, polishes. But when alkanes are fractionally distilled, a nominal, very little amount of alkenes may be present, or less, or no. So alkanes are cracked further to obtain alkenes. Larger alkanes especially are cracked to produce smaller alkanes because they are gas and petrol. You can see that video in alkanes, cracking of alkanes, chemical reactions of alkanes in the same module. Alkanes basically are cracked to obtain what? Alkenes. And alkenes are unsaturated hydrocarbons. They have huge importance in the modern day because they are the starting molecules. Alkenes are starting basic molecule to make any kind of plastics. The polythene, the shopper bags, are polypropenes, for which most of the plastics you see, the good quality plastic, this body of air conditioner or the body of the car dashboard, or alkenes like butene, they are further polymerized to produce polybutene, wonderful plastics of many children wear and parks and stuff and other things. So they are basic molecule for making plastics and synthetic materials, other synthetic materials, other chemicals like alkenes may be changed to alcohols by hydration. So they have huge uses in modern day petrochemicals and plastic industry and the world of polymers. We'll see in the additional polymerization as well in the organic chemistry's applications. So they are unsaturated hydrocarbons. What's basic about them? They are hydrocarbons made up of hydrogen and carbon, and they are unsaturated. That is, at least one carbon double bond carbon is present. Unsaturation, not saturation like alkanes, where each carbon atom was having 4 single bonds and throughout it was single bonds. CnH2n plus 2 was their general formula. But alkenes contain carbon double bond carbon as a functional group. And they obey what? CnH2n as the general formula, not plus 2. It means twice the number of hydrogen as the carbon are present. Suppose CnH2n, C2, H2 into 2, 4. So C2H4. That is basically the starting molecule for the alkene homologous series. So the first molecule, that is ethene, as according to this rule. Eth stand for 2 carbon. They can't have meth because the single carbon atom cannot make a double bond. Eth mean 2 carbon atom, and that is the starting molecule, most basic molecule, smallest member of alkene homologous series, and the most important because large variety of ethene is polymerized to make polythene or plastic. The mark in my hand contain the polythene body, okay, and plenty of other materials are made up of polythene, the cling films, the shopping bags and stuff, and then variety of packing materials you see in a supermarket, they are basically the derivatives of what? Ethene, the polythene, okay. Then comes propene. Propene, the second member of the series, the prop stand for 3 carbon atom. 3 carbon atom according to the rule C3H, N stand for what? Number of carbon atoms. So if N is 3, then 2 into 3, that makes it as what? C3H6. This is how you can apply the general formula to devise an alkene molecule. And C3H6, look at this. If it is ethene, 2 carbon atom, they contain a double bond. You can see their dot and cross structure as well. 2 of the electrons are shared mutually and rest of the 2 electrons are offered to the hydrogen. So each carbon atom has the valency satisfied and 8 electrons around it, and each hydrogen has 2 electrons around it. Same goes for propene. Look at 1, 2, 3 carbon atom, a double bond present. It may be present here or there and anywhere because carbon atom position double bond here or here makes it as propene, no difference, that's flip. And you can also write their condensed formula. Just in alkanes we have seen condensed formula is mostly written mean CH2 double bond CH2. Double bond is shown CH2 double bond CH, this one, and then CH3. All these are what? Hydrogens. This is one hydrogen here because always you need the key thing, the carbon should have maximum valency of what? 4. This is 1, it is 2, this one is 3, and this one is 4. Each carbon atom has 4 valency, whether there is a double bond present. One double bond essential for an alkene molecule, CH2, double bond CH, CH3. And then comes bute. You know, bute means what? 4 carbon atom. 8 hydrogen should be there, CnH2n plus 2, a double bond present here. It may have a double bond in the center, so it means it can be bute 1-ene or bute 2-ene. We'll see, especially in isomerism in alkenes, the next topic, okay? But anyhow, look at the condensed formula, CH2. Condensed formula condenses, shows the position of the carbon and hydrogen atoms. And any functional group that is also shown. Just in alkanes, we have seen the condensed formula. This one is what? Displayed formula, structural formula, showing all the bonds. But this is condensed formula. And this one is what? Molecular formula, okay? So this is the molecular formula, tells us about the exact number of atoms present in the molecule and their kind, 4 carbon, 8 hydrogen. This one is displayed and this one is condensed, okay, structural formula. Butene, pentene, hexene, heptene, all these alkenes have their importance because these alkenes are polymerized to make variety of plastics and synthetic materials, and these alkenes are also derivative for variety of alcohols. Alcohols later on changes to carboxylic acids. So wonderful thing, the crude oil, because basic molecule or alkanes are obtained from there, and alkanes are later cracked to obtain alkenes. And these alkenes are basically modern day. Every material we see around us, the plastic, the synthetics, have some origin from the petrochemicals or crude oil. So we are going to carry on with alkenes properties, especially we'll see the isomerism in alkenes, just as we've seen alkanes in alkanes, and then the chemical properties or chemical reactions of alkenes, okay.